Good evening, children.
Good evening.
Good evening. Good evening. Yeah. So I've given you sufficient time. I shared the videos on trigonometry, the introduction to trigonometry. I'd also shared the notes, which were explained in the videos. And except 2 students, you know it yourself. I'm not mentioning your names. You know it yourself. Except 3 students, the others have submitted the assignment. Yeah. So I'm going to dive into the chapter directly. Now let's recall the, what do we do first? The 3 important trigonometric identities. Who can tell me? The 3 important trigonometric identities. Yes?
Sin square theta plus cos square theta equal to 1.
Sin square theta plus cos square theta is equal to 1.
1 plus cot square theta is cosec square theta.
Okay. Cosecant square theta minus cot square theta is equal to 1.
1 plus tan square theta is secant square theta.
Secant square theta minus tan square theta is equal to 1.
Okay.
I have explained everything in terms of 1. In my videos, I would have expressed everything in terms of 1. It's right. What you said is right. You said cosecant square theta is 1 plus cot square theta and secant square theta is 1 plus tan square theta. That's fine. So I just write everything, is equal to 1. So sin square theta plus cos square theta is 1. Cosecant square theta minus cot square theta is 1. Secant square theta minus tan square theta is 1. Okay, there is no response. What about complementary ratios? What is sin theta? Okay, let me start. Sin theta is equal to cos 90 minus theta. And cos theta is equal to sin 90 minus theta. Now tell me, what is secant theta? These are trigonometric ratios of complementary angles. These are the 6 important trigonometric ratios: sin theta, cos theta, tan theta, sin theta, cos theta, tan theta. The 3 important trigonometric ratios and their reciprocals: cosecant theta, secant theta, and cot theta. They're reciprocals. They're reciprocals. Yeah, now these are what you see here are trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. So secant theta is equal to
cosecant of 90 minus theta.
Cosecant of 90 minus theta, or simply cosecant 90 minus theta. And what is cosecant theta?
Secant of 90 minus theta.
Secant 90 minus theta, yes. So what you see here, secant theta and cosecant theta are reciprocal ratios. Sin theta and cosecant theta are reciprocal ratios. Cos theta and secant theta are reciprocal ratios. Tan theta and cot theta are reciprocal ratios. Now what we're seeing here are trigonometric ratios of complementary angles. Complementary angles. Sin theta is equal to cos. Sin and cos are complementary ratios. Sin and cosecant are reciprocal ratios. Sin and cosecant are reciprocal ratios. Sin and cos are complementary ratios. Cos and secant are reciprocal ratios. But secant and cosecant are reciprocal ratios. Complementary ratios. So reciprocal, only tan and cot are both complementary as well as reciprocal ratios, because tan theta is cot 90 minus theta, and cot theta is tan 90 minus theta. Tan 90 minus theta. The reciprocal ratios and the complementary ratios. Sin theta is equal to 1 by cosecant theta, or cosecant theta is equal to 1 by sin theta. Cos theta is equal to 1 by secant theta. Secant theta is equal to 1 by cos theta. Tan theta is equal to 1 by cot theta. Cot theta is equal to 1 by tan theta. Reciprocal ratios. Reciprocal ratios. Reciprocal ratios. These are complementary ratios. Complementary ratios. These are complementary ratios. So see, sin theta is not equal to cosecant theta. Sin theta is not equal to, see, like 5 is not equal to 1 by 5. The reciprocal of 5 is 1 by 5. The reciprocal of 5 is 1 by 5. But 5 is not equal to 1 by 5. The reciprocal of 5 is 1 by 5. Similarly, when we say that sin theta and cosecant theta are reciprocal ratios, 5 and 1 by 5 are reciprocals of each other. 5 and 1 by 5, or 7 and 1 by 7, or 2 by 3 and 3 by 2 are reciprocals of each other. Doesn't mean that they are equal. You cannot write 2 by 3 is equal to 3 by 2. The reciprocal of 2 by 3 is 3 by 2. The reciprocal of 1 by 7 is 7. Similarly, sin theta and cosecant theta are reciprocal ratios. So you cannot write sin theta is equal to cosecant theta. Sin theta is equal to 1 by cosecant theta. Ask yourself, how can you say sin theta is equal to cosecant theta? Sin theta and cosecant theta are reciprocal ratios. So sin theta is equal to 1 by cosecant theta, or cosecant theta, because they're reciprocals of each other. Sin theta and cosecant theta are reciprocals of each other. So sin theta can be written as 1 by cosecant theta. Cosecant theta can be written as 1 by sin theta. Sometimes teachers pronounce cosec theta. Well, I'm used to cosecant. Cosec theta, sec theta. No, I'm not used to saying that. Yeah, I say cosecant theta and secant theta. Sometimes cosecant theta is pronounced as cosec, in short, cosec theta. Cosec. So what you say cosec is cosecant. I say cosecant. And sec theta. Again, I'm not used to that. Sec theta. No, I can't say that. So secant theta. Sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. So here we see that sin and cosecant, sin theta and cosecant theta are reciprocals of one another. Similarly, cos theta and secant theta are reciprocals of one another. So we say cos theta can be replaced with, if you want to replace cos theta, it can be replaced with 1 by secant theta. Or you want to replace secant theta, you can replace secant theta with 1 by cos theta. And here tan theta and cot theta. Tan theta and cot theta are reciprocals of each other. Tan theta is equal to 1 by cot theta. Cot theta is equal to 1 by tan theta. So remember, sin theta is not equal to cosecant theta. Cos theta is not equal to secant theta. And tan theta is not equal to cot theta. They are reciprocal ratios. On the other side, so on the left side, you see the complementary ratios. Sin theta is equal to cos 90 minus theta. Sin and cos are complementary ratios. Sin theta is equal to cos 90 minus theta. Cos theta is equal to sin 90 minus theta. Similarly, secant and cosecant are complementary ratios. Secant and cosecant are complementary ratios. Secant theta is equal to cosecant 90 minus theta. Cosecant theta is equal to secant 90 minus theta. Tan theta and cot theta. Tan and cot are both, when you under reciprocal ratios, you can see tan and cot together. Under complementary ratios also, you can see tan and cot together. Tan theta is equal to cot 90 minus theta. Cot theta is equal to tan 90 minus theta. So these are about reciprocal ratios and complementary ratios. What we first saw were the three important trigonometric identities. Sin square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. So the important trigonometric identities. Here you see on the slide, you see the reciprocal ratios and the complementary ratios. And then the other thing you need to know is the table containing the values for some standard angles. The table containing the values of some standard angles. What is sine 0 degrees? What is sine 30 degrees? What is sine 45 degrees? So the standard angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. 0, 0, 30, 45, 60, and 90. These values you need to memorize. So what is the value of sine 30? Sine 0.
சரி இப்படி பேச ஆரம்பிச்சீங்கன்னா எனக்கு ஒண்ணும் புரியாது. ஏய் இது
Disable your mic. So these are the standard angles, 0 degrees, 30 degrees, 45 degrees, 60 and 90 degrees. So you need to remember the values of sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees. Similarly, cos 0 degrees, cos 30 degrees, cos 45 degrees, cos 60 degrees, cot 90 degrees, cos 90 degrees, tan, cosecant, secant, and cot. So these are the standard angles, 0, 30, 45, 60, and 90. So you have a table where you have these values. Meaning you have it in your book. You have a table, meaning you have it in your book. The table showing the 6 T ratios and the standard angles with their values. So these are the different parts of the chapter. So one part of the chapter where you will have to prove trigonometric identities using the standard ones. You will have to prove trigonometric identities using the standard identities. The standard identities are what we discussed initially. Sin square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. These are the three basic or the standard trigonometric identities. So using these three identities, we have one part of the chapter where we'll have to prove other trigonometric identities. Using these three standard trigonometric identities. So like we have seen algebraic identities, no? A plus B the whole square is equal to A square plus 2AB plus B square. A minus B the whole square is equal to A square minus 2AB plus B square. So these are algebraic identities. Why? Because they involve variables. These are algebraic identities. We call them algebraic identities because they involve variables. Variables A, B or variables X, Y, Z. So 9th standard again, x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z, x square plus y square plus z square minus xy minus yz minus xz. So this is an algebraic identity because it involves variables x, y, and z. It's an equality. An identity is an equality. An identity is an equality, which is true for all values of the variables involved. An identity, an algebraic identity is an equality. An identity is basically an equality. An identity is an equality. Why we say it's an equality? Because we have two sides, no? We have two sides. A plus b the whole square is equal to a square plus 2ab plus b square. It's an equality. Equality is anything that involves the equal to sign. A minus b the whole square is equal to a square minus 2ab plus b square. So an identity is basically an equality. It's an equality. An algebraic identity is one which involves variables a, b, c, x, y, z. A trigonometric identity is an identity which involves trigonometric ratios. A trigonometric identity. Again, here an identity is an equality. When we say trigonometric identity, an identity, every identity is an equality. And we call them trigonometric identities because these identities involve trigonometric ratios like sine theta. It need not be theta. The angle can be theta or A, B, C, anything. You can say sine A, cos A, tan A, if the angle involved is A. So we say trigonometric identities because these identities involve trigonometric ratios like sine theta, cos theta, tan theta, secant square theta, cosecant square theta, cot square theta. So since these identities involve trigonometric ratios, we call them trigonometric identities. Algebraic identity because it involves variables. An identity is an equality, which is true for all the values of the variables involved. Or here in this case, you will have some angles involved. Because sine theta, when we say theta, theta is an angle, which is true for the angles involved in the identity. All values of the angles involved in the identity. But here we restrict our discussion to acute angles only. In standard 10, we restrict discussion of trigonometric ratios to only acute angles. We have T ratios for angles, beyond 360 also. We have sine of 1000 degrees, any angle, basically. So that you will see in 11th and 12th standard. Angles more than 90 degrees, you will see in 11th and 12th standard. So you have angles more than 360 degrees also, but we will restrict our discussion to trigonometric ratios of acute angles. Okay, so talking about the different parts of the chapter. So I was telling you that one part involves proving trigonometric identities. Some other trigonometric, there are many trigonometric identities. You cannot remember all of them. So it's about proving other trigonometric identities using these three basic trigonometric identities. Sine square theta plus cos square theta is 1 and so on. And then there's one part of the chapter where you have to solve using complementary ratios. Using complementary ratios. Another part where we use reciprocal ratios. And then one part where we use the values from the table. So you can see the chapter in 4 parts. Where one part where we use the tables, the values in the table to answer the questions. And then second part, you can say complementary ratios. Then the third part, reciprocal ratios. And finally, the identities. Okay, so now I just want you to have an idea about the whole chapter, a glimpse of the whole chapter. So how can we do that? So I'll introduce you to a variety of questions from the entire chapter. So if you've already learned it in school, it may be easy for you. I don't know. If you've not learned it in school, it may be like, it's confusing or difficult. Everything is easy when you put it to practice. When I see something for the first time or when I read something for the first time, it really is intimidating. I feel no, it's beyond my strength to remember or understand or remember it. But once you practice it, it becomes easy. If you can understand, with practice, you can remember. If you don't understand, ask me. I have to explain till you understand. That's my job. So at the end of it, you will understand. You will be made to understand. So next, what you have to do is practice so that you can remember. For retention, you have to practice. So my part I'll do. Your part you have to do. And you will all do it. I know that. But I'm sorry, children, those who have not visited the videos or simply copied the notes, from the pictures I had shared with you. If you have simply written out everything just for the sake of submitting the assignment without watching the videos, see, you have to help yourself. I shared the videos with you long back. So after today's class, if you have not watched the videos, but simply written the notes and submitted it to me, please use the videos, watch the videos, understand the introduction to the chapter, and then watch today's video also. Then things will become clear. You have to watch those YouTube videos. That is the first step. Do that and then watch today's video after I share it with you. Then it should be fine. And children, I wanted to say this. Now we have class, use the emoji, raise your hand. Tarun, Murali, Nandini, Ananya, Rajeshwari, Rajarajeshwari, Kanishka, Hitesh, Ashmin, Shreys, Murali, Krishna, Pranav, Priyanka, and Taruni. Murali, Krishna, you're coming running from somewhere. Pranav, Rajan. Priyanka and Taruni. Why delay, Taruni? No answer. Priyanka? Are you there, Priyanka?
Mom, I went to drink water, Mom. Mom, can you hear me?
Yeah. Oh, sorry, I didn't acknowledge. Okay, Taruni, fine.
Yes.
I thought you would have seen me nodding my head. Okay, yeah, I heard you. Yes. Yeah, I didn't complete this. So children, we have completed linear equations, statistics, polynomials. Now we have started trigonometry. Now, so there will be 4 playlist links. All the meeting recordings are in 4 playlist links. There's one playlist link for linear equations, another one for polynomials, statistics, everything was covered in the YouTube videos. If you watch the videos, you know the entire chapter. Anyways, when talking in terms of playlist, there is one playlist for linear equations, one for polynomials, one for statistics, and one for trigonometry. Just have the playlist. Today, I'll share all the playlist links. Today, I shall share all the playlist links. Now we have started trigonometry today, right? So after today's class, I'll download this recording and upload it in the playlist link. So there'll be only one video, right, in trigonometry. Trigonometry playlist link will have only one video because today's class is the first class on trigonometry, so there'll be one video. Now you have the playlist link with you. As and when we finish classes on trigonometry and I keep uploading the videos in the playlist link, the playlist will get updated. So with the same link, you can see all the videos. I don't have to share the recordings. Every day's recordings, I don't have to share with you. You can use the playlist link. You can see all the videos in it, uploaded. As and when I upload, the link gets updated. If you have the link of a particular meeting recording, then that is of that particular meeting recording. But if you have the playlist link for the chapter, this chapter trigonometry has a playlist link. So this playlist will have all the videos on trigonometry. So if you save this playlist link, you can simply tap on that. Supposing you missed the third class on trigonometry, you don't have to ask me for the recording. So at the end of the class, or maybe the next day, if you use the same playlist link, you can see the updated uploaded videos in it. So you need not request. I forgot to share it. I forgot to share this information with you. So every time, I upload videos in the playlist link, the link gets updated. You can use that link, the playlist link, to watch any video, to watch any meeting recording. Yeah. Yeah, that's the first one. So we'll see how to do this. Now we need to understand, there are varieties, so many types of questions in trigonometry, so many types. That's so beautiful that it's easy to remember all of them, It's all about understanding the question. So see, if sine of A minus B, see, with sine you can have only one angle here. So A minus B, so maybe A is 60 degrees, A can be 60 degrees, B 30 degrees. See, we'll talk only in terms of standard angles. Only in terms of standard angles. So 60 degrees and 30 degrees. It doesn't mean only these values exist. All values exist. 0 degrees to anything exist. We are dealing only with these standard angles. So A minus B is the angle. Sine of, when we say sine of A minus B is the angle. So like supposing A is 60 degrees and B is 30 degrees. 60 minus 30. So sine 30 degrees. Sine 30 degrees it is. If A is 60 degrees and say B is 45 degrees, then 60 minus 45, A minus B is 15. So sine of 15 degrees it is. So this is basically the formula which is given to you. Sine of A minus B can be calculated using this formula. Sine A cos B minus cos A sine B. So this is actually a formula that helps you to find sine of a particular angle. Sine of A minus B is equal to sine A cos B minus cos A sine B. This is actually a formula that can help you. That helps you to calculate the sine of any particular angle. Similarly, this is a formula. This is a formula. Cos of A minus B. So A minus B is an angle. A minus B is an angle. Cos of A minus B is equal to cos A cos B plus sin A sin B. So basically, there are two formulae given to you. You need to use the appropriate formula to find the value of sine 15 degrees and cos 15 degrees. So you should use this formula. To find sine 15 degrees, use this formula, sine of A minus B. And to find cos 15 degrees, use this formula, cos of A minus B. To find sine 15 degrees, we'll use this formula, sine of A minus B is equal to, we'll use this formula. And to find cos 15 degrees, we'll use this formula, cos of A minus B is equal to, okay. Now, how do we So let's talk about sine 15 degrees, computing sine 15 degrees. How do we find sine 15 degrees? Using the formula sine of, using the formula sine of A minus B is equal to sine A cos B minus cos A sine B, using this formula. But this is A minus B. We need sine 15 degrees. So you need to assign some angle to A and B so that you get 15 degrees. So A can be 60 degrees and B 45 degrees. Or you can take A as 45 degrees and B as 30 degrees. Standard angles, okay, always. Because 60 minus 45 is 15 degrees. Similarly, 45 minus 30 is also 15 degrees. So you can take any one of the two pairs, Let A be equal to 60 degrees and B be equal to 45 degrees. So A minus B, 60 minus 45, 15 degrees. Or you can take this pair. Let A be equal to 45 degrees and B be equal to 30 degrees. So 45 minus 30 is 15 degrees. Use any one of the two assumptions. Okay, so supposing you use the first one or the second one, see anything. Supposing you use the first one, what do you get? 60 degrees minus 45 degrees is equal to, now what do I'll have to construct this formula using A for 60 and B 45. So what do I write here? Sine, what is A? What is A?
Sine 60.
60 degrees. Cos
45 degrees.
minus cos
Cos 60 degree, sine 45 degree.
45 degrees. Now what is 60 minus 45?
Sine 15.
15 degrees is equal to, now where will you get the value of sine 60 from? We'll just say table. So where will we get these values from? From the table. In the table, we have the value of sine 60 degrees. Sine 60 degrees is root 3 by 2 into cos 45 degrees, 1 by root 2. You need to remember this. Minus cos 60 degrees, 1 by 2. Sine 45 degrees, 1 by root 2. Simplify this. This you know how to simplify. Simplify this and you will get the value of sine 15 degrees. That's all. Simplify this and you will get the value of sine 15 degrees. Similarly, you need to work cos 15 degrees. Yes. Work, children. Write down the question. You can see the answer. Of course, if the denominator is irrational, you'll have to rationalize it. Let me know once done, children. Please write the question, complete the working, complete the answer. Any doubts you can ask me. I'll just get back in 2 minutes. Done, children?
1 minute, ma'am.
Yeah. How many of you have learned trigonometry in school already?
They finished the introduction and applications of trigonometry.
Both, that is heights and distances. You finished both the chapters in school.
Yes, ma'am. Yes, ma'am.
Okay. Done, children? Other schools? Tarun Murali?
Ma'am. Ma'am did not start in KNMS, ma'am.
Tarun Murali, you're from KNMS, huh?
Ah, yes, sir.
Tarun Murali? Okay. Nandini?
Yes, ma'am.
Yeah. Have you learned trigonometry in school?
No, ma'am, not yet.
Not yet. Rajeshwari?
Ma'am, they have started, ma'am.
Just started, huh?
Yes, ma'am.
Okay. Kanishka?
They didn't start it, ma'am.
Okay. Hitesh, because maybe you belong to a different section of KNMS and you might have learned it. Hitesh? Yes,
They
no?
didn't start.
No. Sashmin?
Yes, ma'am.
You finished trigonometry in school?
Yes, ma'am.
What about applications of trigonometry?
Not, they have not started that yet, ma'am.
Not yet, huh?
Not yet.
Shreyas?
No, ma'am, not yet started.
Murali Krishna?
No, ma'am.
No. Pranav? Priyanka?
They haven't started yet, ma'am.
Okay. Tarun E?
Ma'am, they didn't start it at me.
Okay. Tarun Murali? Can you hear me?
Yes, ma'am.
You're from KNMS or Z school?
Z school, ma'am.
Okay. You said you have not learned, right, in school?
No, ma'am. Yes, ma'am.
Yes. Yes or no? Have you learned or no?
Ma'am, I have not learned, ma'am. They not started.
Okay. Okay. All right. So only Ananya's learned trigonometry in school. Fine. Ananya and Sashmin also said yes, I think. Sashmin, you said you're finished, right?
Yes, ma'am.
Yeah, okay. Yes, children, any questions here? So this is the formula. This is the formula. And using this formula, we are going to find the value of sine 15 degrees. So we assign 45 degrees to A and 15 and 30 degrees to B, because 45 minus 30 will give us 15 degrees. You can also take 60 degrees and 45 degrees. You will get the same answer. You can also take 60 and 45 for A and B, because 60 minus 45 is also 15. So now this gives you sine 15 degrees, and here you'll have to get the values from the table. Then this product is root 3 by 2 root 2. This product is 1 by 2 root 2. Common denominator 2 root 2. Common denominator 2 root 2. So you get root 3 minus 1 in the numerator. This is what you get. Root 3 minus 1 by 2 root 2. Root 3 minus 1 by 2 root 2. Now the denominator is irrational. So we rationalize the denominator like this. We multiply the numerator and denominator by root 2. This we always do. When the denominator is irrational, you will have to always rationalize the denominator. So that's why this one. And then this is the value with the rational denominator. Root 6 minus root 2. Similarly, using this formula, we are going to find the value of cos 15 degrees. So again, not that if you use 45 and 30 here, you should use 45 and 30 only here. Nothing like that. Here you can use 60 and 45. You can use 45, 30 here, and you can use 60 and 45 here. You can change the values of A and B here. Okay. So same thing. So wherever there's A, we use 45, B, we use 30. These values are from the table. These values are from the table. And then on simplifying and then rationalizing the denominator, we get root 6 plus root 2 by 4. Now, we know that sine theta is equal to cos 90 minus theta. We know that sine theta is equal to cos 90 minus theta. Now we have here sine 15 degrees. So theta is 15 degrees. Theta is 15 degrees. So sine 15 degrees is equal to cos 90 minus 15 degrees. Instead of theta, we say 15. Instead of theta, we say 15. So we know that sine theta is equal to cos 90 minus theta. Complementary ratios. Sine theta is equal to cos 90 minus theta. So sine 15 degrees will be equal to cos 90 minus 15 degrees. So sine 15 degrees, the value of sine 15 degrees is the same as the value of cos 75 degrees. The value of, now what is the value of sine 15? Root 6 minus root 2 by 4. The same is the value of cos 75 degrees. Cos 75 degrees is also root 6 minus root 2 by 4. So cos 15, we know that cos theta is equal to sine 90 minus theta. Cos theta is equal to sine 90 minus theta. Cos 15 degrees. Cos 15 degrees. So theta is 15 is equal to sine 90 minus, instead of theta, use 15. So what do you get? Cos 15 degrees is the same as the value of cos 15 degrees is the same as the value of sine 75 degrees. The value of cos 15 degrees is the same as the value of sine 75 degrees. So what is cos 15 degrees? Root 6 plus root 2 by 4. So sine 75 degrees will also be root 6 plus root 2 by 4. The value of cos 15 degrees is the same as the value of sine 75 degrees. Cos 15 degrees is root 6 plus root 2 by 4. So sine 75 will also be root 6 plus root 2 by 4. If tan theta is equal to 2mn by m square minus n square. If tan theta is equal to 2mn by m square minus n square, find the values of other t ratios of theta. So T ratios meaning trigonometric ratios. T ratios meaning trigonometric ratios. All right. Find the values of other T ratios of theta. What are the other T ratios? So here we have 1, tan theta we have. What are the other ratios of theta? Sin theta, cos theta, tan is here. So cosecant theta, secant theta, and cot theta. These are the other T ratios. Trigonometric ratios. These are the other trigonometric ratios of theta. The angle is theta. So the question says, given the value of one trigonometric ratio of theta, given the value of one trigonometric ratio of theta, that is tan theta is given to you. What is tan theta? 2mn by m square minus n square. The value of one t ratio of theta is given to you. One trigonometric ratio of theta. That one trigonometric ratio of theta is tan theta. So tan theta is equal to 2mn by m square minus n square is given to you. Using this, you should find the other t ratios of theta. That is, you should find sine theta, cos theta, cosecant theta, secant theta, and cot theta. Now, you don't have to find everything because when you know tan, you automatically know cot, because we know that sine theta and cot theta are reciprocal ratios. We know that tan theta and cot theta are reciprocal ratios. We know that if tan theta is 2mn by m square minus n square, then cot theta is the reciprocal of tan theta. So cot theta will be m square minus n square by 2mn. Because we know tan theta, it's easy to find cot theta. Reciprocal of tan theta. Next, maybe we can find sine theta. If you find sine theta, you can immediately find cosecant theta. Because sine theta and cosecant theta are reciprocal ratios. See, you're given tan theta, so you immediately know cot theta. Next, we'll try to find sine theta. If you find sine theta, its reciprocal is cosecant theta. Its reciprocal is the value of cosecant theta. And maybe if we find cos theta, its reciprocal is secant theta. So see here, we are given tan theta. So it's enough if you find sine theta and cos theta. Because the reciprocal of tan is cot. The reciprocal of sine is cosecant. And the reciprocal of cos is secant. So we know this, so we know this also. Then now we'll find this and this. The reciprocals will give you this and this. So it's not that we'll have to find the remaining 5, all the remaining 5. Just find sine and cos. You can find all the others. So we have the 3 basic ratios, sine theta, cos theta, and tan theta. If you have these values, the reciprocals will be cosecant theta, secant theta, and cot theta. Now you can find the values of other t ratios of theta in more than one way. So you can, this is how I put it. You can, find the values of the other t ratios of theta using a right triangle. You can find the values of the other t ratios of theta. The other trigonometric ratios of theta you can find by using a right triangle or by using trigonometric identities. You can use trigonometric identities to find the other t ratios, the values of the other t ratios, or you can also use a right triangle. Right triangle is easy. Easy meaning you can work quickly, faster. When you work with identities, you'll have to work carefully. That's all. Simplification, you need to do some smart work there. But we will learn both the methods because, the idea is to become smarter. All right. So we'll learn both the methods. We'll understand both the methods. So one is using right. See, always. This is always. That is given one t ratio. You can find the other t ratios using a right triangle. You can remember this like a formula. Given one t ratio, that is given the value of one t ratio. You can find the values of the other t ratios using a right triangle or using trigonometric identities. Given the value of one trigonometric ratio of theta or whatever angle, it can be of theta or of angle A, B, whatever. You can find the values of the other t ratios of theta using a right triangle or by using trigonometric identities. So first we'll see using a right triangle. So using a right triangle is very simple. Calculation is very simple. So just take up a right triangle and you remember that theta is always an acute angle. theta is always an acute angle. That is, the angle that goes along with the trigonometric ratio is always an acute angle. The angle, so sine of something, right? That's always an acute angle. We are studying only for acute angles in 10th standard. Okay. So you can call the triangle. Lower your hands, class. Priyanka, are you there in the meeting? I called out to you earlier. There was no response. You have some problem with the mic? Murali Krishna, are you there? Looks like these people have some exam at school tomorrow. So they're preparing for the exam.
Yes, ma'am, I am there, ma'am.
There, okay. Priyanka, why no response?
Ma'am, I couldn't hear you, ma'am.
You couldn't hear me.
Yes, ma'am. For some time it was unclear.
Okay, did you miss any part of the explanation?
Yes, ma'am. Some part, ma'am. That's what I was seeing.
Okay, tell me, this previous one?
Yes, ma'am. I understood this, ma'am.
Okay. Okay, so given one trigonometric ratio, to find the other t ratios, you can use a right triangle. We'll understand that method first. So take up a right triangle. So one of the angles is the right angle. The remaining two are acute angles. You can mark off anything as theta. You can call this theta or this one theta. Any one acute angle is theta. Anything, this one is theta. You can, if you want, name the triangle ABC. You can call it ABC, PQR. Okay, so name the triangle and mark off any one acute angle as theta. Now, what is tan theta? Tan theta connects the opposite side and the adjacent side. Tan theta is equal to the side opposite to theta by the side adjacent to theta. When we say tan theta is opposite by adjacent, it is a side opposite to theta by the side adjacent to theta. Which is a side opposite to theta? This one is the opposite side. And the side adjacent to theta is this one, adjacent. This is always the hypotenuse in this triangle because it's opposite of the right angle. So this one is the hypotenuse. It's opposite of the right angle. This one is opposite of the right angle, so it's a hypotenuse. Now the opposite and adjacent side depends on the angle, whichever angle is considered. So with respect to this angle theta, this is the opposite side and this is the adjacent side. Now what is tan theta? Opposite by adjacent. So opposite by adjacent is 2mn by m square minus n square. Tan theta connects the opposite and the adjacent side. So opposite, this one is 2mn and the adjacent, this one is m square minus n square. So you know you can use Pythagoras theorem to find the hypotenuse, to find the value of the hypotenuse. So when you have a t ratio, use a right triangle. The t ratio will connect two sides. The t ratio will connect two sides of the triangle, the right triangle. So fill those two sides. So anyways, of the three sides, from the t ratios, you will get the values of two sides. The trigonometric ratio will connect two sides, opposite, adjacent, or opposite and hypotenuse, or adjacent and hypotenuse. So you will get, for two sides, you will get some values. Third side you can use, you can find using Pythagoras theorem. The value of the third side you can find using Pythagoras theorem. So somehow you can find the values for all the three sides of the triangle. Then what? Find the t ratios. That's all. So now I'll just write something. Okay, I'm just writing m square plus n square. I don't know if this is the value. I'm just writing m square plus n square. So now I find, excuse me. So we find the hypotenuse using Pythagoras theorem. All right. And we get m square plus n square. Now tell me, what is the value of sine theta? Sine theta is equal to opposite by hypotenuse. Opposite by hypotenuse. So what is opposite here? 2mn. The hypotenuse m square plus n square. This is the value of sine theta. What's the value of cos theta? Cos theta is equal to adjacent side by hypotenuse. Adjacent by hypotenuse. Adjacent is what? M square minus n square. And what is the hypotenuse? M square plus n square. That's all. Like this, you should write everything. That's all. So what? You're given one T ratio. Use the T ratio and fill the sides in the right triangle. The third side you find using Pythagoras theorem. Now you have some values for all the three sides. Find the T ratios, the other T ratios. That's all. Write down, children. Write down. So tan theta is equal to, please write the question, draw the figure. You can just write is equal to, maybe you can write tan theta is equal to opposite by adjacent. See, BC, supposing you don't understand how suddenly she's written root of all this, from where do you get all this? You write all the steps. If you cannot write this straight away, you write all the steps. You know that BC square is equal to AB square. AB square plus BC plus AC square, or AC square plus AB square. You know this. So BC is equal to the square root of AC square plus AB square. So I've written that straight away. BC is equal to square root of AC square. What is AC square? AC, what is AC? This one, m square minus n square, the whole square, plus AB square plus 2mn, the whole square. I've written this straight away. First write this one, tan theta is equal to opposite by adjacent, 2mn by m square minus n square, which is given. Fill it in the right triangle and find the hypotenuse, BC. This is the formula, root of AC square plus AB square. That's what I've used here. You can maybe include these steps. Now at this point, it looks like A minus B the whole square. It looks like A minus B the whole square. See here, it looks like A minus B the whole square plus 4AB, 4AB. A minus B the whole square plus 4AB. So A minus B the whole square plus 4AB is A plus B the whole square. So you can use identities to save time in simplification. See here, remember this main identity. Remember this one, A plus B the whole square minus A minus B the whole square is equal to 4AB. You can write this in the margin. Remember this alone. A plus B the whole square minus A minus B the whole square is equal to 4AB. Now transpose and find. Now here this is like A minus B the whole square plus 4AB. So what is A minus B the whole square plus 4AB? A minus B the whole square. So transpose this. So A plus B the whole square minus 4AB is equal to A minus B the whole square. A plus B transpose. A plus B the whole square minus 4AB is equal to A minus B the whole square. So that's what it looks like. It looks like A minus B the whole square plus 4AB. So the result is A plus B the whole square, where A is M square, where A is M square, A is M square and B is N square. So using the identity, you get root of m square plus n square the whole square. A plus b the whole square. A is m square, b is n square, the whole square. So BC is equal to m square plus n square. Because whole square, notice BC is equal to root of this one 2 times. M square plus n square 2 times. So BC is equal to m square plus n square. So we got the hypotenuse. Hypotenuse is m square plus n square. Now find the other t ratios. Sine theta, opposite by hypotenuse. So once you find sine theta, you can find cosecant theta, reciprocal of this one. Cos theta, adjacent by hypotenuse. Once you find cos theta, its reciprocal is secant theta. And cot theta is 1 by tan theta, the reciprocal of tan theta. So that's given to you already. Reciprocal of tan theta is cot theta. The first line I wanted you to write it like this. Tan theta is equal to opposite by adjacent, which is 2mn by m squared minus n squared given. This is the first line. And here, if you want, you can include BC square is equal to AC square plus AB square. So BC is equal to square root of AC square plus AB square. And this will be the next step. After that, this will be the next step. So children here also, I'll just update the, this PPT tomorrow, meaning by the next class. Here also children, you can write here cosecant theta is equal to 1 by sine theta. Please write it like this. Cosecant theta, it's not wrong, please, it's not wrong. I just missed to write this, is equal to 1 by sine theta. That is equal to m square plus n square by 2mn. Just write that. Then secant theta, here also just write secant theta is equal to 1 by cos theta. That is the reciprocal of cos theta. And the reciprocal of cos theta is m square plus n square by m square minus n square. Please write it like this. Children, at least by the class on Saturday, please go through the, videos, the YouTube videos I had shared on trigonometry, please, because most of us, Ananya's learned, so it's revision for her. However, I think in most schools we work only from NCERT. I don't think you would be solving many problems away from NCERT. So anyways, this you will find most of the sums new. Though you have learned it in school, you might have learned it in school. You will find many questions, new to you. I'm sure about that. It's not just going to be a repeat. So it's definitely, useful for even those students who have learned trigonometry already in school. Others, please watch the videos so that, the first impression is important. The first impression on trigonometry should be that it is as easy as, anything else. So when you don't have the introduction clearly, and when I do it in the class, if it looks like difficult for you, if that becomes your first impression, it may always remain the same for you. I don't want that to happen in spite of attending my classes. Kindly help me by watching the YouTube videos. Done, children? Finished writing?
Yes, ma'am.
Yes.
Okay. So this AB by AC is nothing but sine theta is equal to opposite by adjacent. I'm sorry, opposite by hypotenuse. Sine theta is equal to opposite by hypotenuse. That's what I've written, AB by BC. Because sine theta connects the opposite side and the hypotenuse. Opposite is AB. Opposite is AB. And hypotenuse is BC. So AB by BC. Once you find sine theta, cosecant theta is a reciprocal of sine theta. So reciprocal of sine theta, m square plus n square by 2mn. Cos theta. How do you find cos theta? Cos theta connects the adjacent side and the hypotenuse. So adjacent is AC by the hypotenuse BC. AC by BC. Adjacent by hypotenuse. AC by BC. So write out AC by BC here. And once you find cos theta, it's reciprocal, secant theta. Secant theta is equal to 1 by cos theta. So write its reciprocal here. And then tan theta is a reciprocal of, cot is a reciprocal of tan. Tan was already given to you here. So it's reciprocal. M square minus n square by 2mn. Just a minute, children. There's somebody at the door. I'll just come back. Go through this alternate method, children. I'm just coming. Yes, children. So I was telling you that the alternate method is to, use the trigonometric identities. So since you're given the value of, tan theta, since we're given tan theta, we're going to make use of a trigonometric ratio that has tan theta in it. We're going to make use of, I'm sorry, I'm just distracted. I'll just, yeah. So I was telling you that the alternate method to find the other t ratios is by using the trigonometric identities. So we have three identities. Which one to use first? So since we're given the value of tan theta, we will use an identity that has tan theta in it. So obviously secant square theta minus tan square theta is equal to 1 is the identity. Secant square theta minus tan square theta is 1. Now you may think that tan theta, if you have tan theta, you also have cot theta, right? Because the reciprocal of tan is cot. See, I'll tell you, when we talk, we may say sine, cos, tan, but you know, in reality, there's nothing like sine, cos, tan. The ratio does not exist without the angle. Now, when we say sine, it is with reference to an acute angle. When we say sine, it's with reference to an angle. So sine sine theta or sine of angle A. It's actually sine of angle A like this, but we don't use this angle symbol. We simply say sine A or cos A, cos of angle A, cos of angle C. So the trigonometric ratios are meaningful only with respect to an acute angle. I'm saying acute angle because our study is restricted to acute angles. So simply saying, see, I might say sine, cos, tan. That's just to, you know, talk faster. Otherwise, there is nothing like sine, cos, tan. Sine, theta. Sine and theta are not separable. Like in algebra, when we say xy, it is x into y. In algebra, when we say xy, it's the product of x and y. It is x into y. It is x into y. In algebra, when we say x, y, z, it's the product of x, y, and z. But in trigonometry, when we say sine theta, it is not the product of sine and theta. It is not sine into theta. This is meaningless without an angle. Sine theta is not the product of sine and theta. Sine theta or cos theta is not the product of cos and theta. In cos and theta are not separable. They are inseparable. So you cannot, it's not cos separately, theta separately. Cos theta is one thing. Cos theta is one thing. The trigonometric ratio is meaningful only when it is used with a reference angle. So this is the reference angle. The reference angle is theta. Or the reference angle is, gamma. Or the reference angle is alpha. Or the reference angle is C. Okay. So sine theta is not the product of sine and theta. Yeah, so when you have tan theta, when you're given tan theta, that means cot theta. Cot theta is equal to m square minus n square by 2mn. So you can also use a trigonometric ratio which has cot in it. You can also use cosecant square theta minus cot square theta as 1. You can also use that. Cot theta is equal to m square n minus n square, the reciprocal of tan theta by 2mn. So you can use this identity, secant square theta minus tan square theta is equal to 1. Or you can also use the identity cosecant square theta minus cot square theta is equal to 1. You can use any one of the two. So if you want to use tan theta directly, you can use this identity. If you want to use cot theta, you can use this identity. When you use this one, you will find secant theta. And when you use this one, you will find cosecant theta. Okay, so that's how I have started. I have made use of a trigonometric identity. I made use of this one, secant square theta minus tan square theta is 1. Now here, since we know tan square theta, we have to find we know tan theta, so we have to find secant theta. So secant square theta is equal to 1 plus tan square theta. So secant square theta is equal to 1 plus, we have the value of tan theta, substitute that. It's tan square theta. What is tan square theta? Tan square theta is tan theta into tan theta. Tan square theta. Tan theta into tan theta is tan theta the whole square. Tan theta the whole square. which is written as tan square theta, which is written as tan square theta. Now sine theta into sine theta into sine theta is equal to sine theta the whole power 3. Sine theta the whole power 3, which is written as sine cubed theta. Sine cubed theta. We write the 3 here. If there's another theta, sine theta to the power 4 or sine to the power 4 theta, like this. So when we say sine square theta, it's the product of sine theta and sine theta. Sine square theta, sine theta into sine theta. Sine square theta is sine theta into sine theta. Like a square is a into a. Sine square theta is sine theta into sine theta. Sine theta into sine theta, sine theta the whole square, which is written like this, sine square theta. It's written like this. So when we have to fill tan square theta, that means tan theta whole square. Tan theta whole square. This is tan theta. This is tan theta. This is tan theta. It's given to us whole square. Why whole square? Because tan square theta is tan theta the whole square. This is nothing but tan theta the whole square. Whole square. So write the value of tan theta which is given to us on whole square. Now when you square this, you will get 4m square n square. And here m square minus n square the whole square. Square it. Square the numerator, square the denominator. So secant square theta is equal to 1 plus. When you square the numerator, you get 4m square n square. When you square the denominator, it is m square minus n square the whole square. Now we have 1 plus something. So common denominator. Common denominator, LCM. The LCM is this one. This one is the LCM. You can see it here. That's the LCM. You can see it here. So you'll have to write that here because 1 is multiplied with this. 1 into this is the same thing. M square minus n square the whole square. This is something which you already know. Taking the common denominator. See, we have 1 plus something. So common denominator for the whole thing. This is the denominator. M square minus n square the whole square. This is the denominator. So this will come here. That's what you see here. In place of 1, this one. Plus 4m square n square. And this identity is so useful, you know, in saving your time. It's so useful in saving your time. Please remember this: a plus b the whole square minus a minus b the whole square is equal to 4ab. Just remember this and you can transpose and find the others. Now this looks like what for you? This looks like a minus b the whole square. This looks like a minus b the whole square plus 4ab. A minus b the whole square, where a is m square, b is n square. A is m square, b is n square. This is like a minus b the whole square plus 4ab, 4m square n square, 4ab, 4m square n square. A is m square, b is n square. So it's of the form a minus b the whole square plus 4ab, which is a plus b the whole square, a plus b the whole square. So the numerator becomes a plus b the whole square. The numerator becomes a plus b the whole square. A is m square, b is n square, the whole square. See, when you call this a minus b the whole square, this related. A is m square, b is n square, 4ab, 4m square n square. It's a plus b the whole square. This one is a plus b the whole square. So a plus b the whole square meaning a is m square, b is n square. A plus b, m square plus n square, the whole square. By the denominator as it is. The denominator as it is. So now you can see the numerator is a perfect square. The denominator is also a perfect square. Both the numerator and the denominator are perfect squares. So secant square theta is this. secant theta is equal to square root of what you see on the RHS. Square root of that. So secant theta is equal to, this is whole square, right? So secant theta will be equal to m square plus n square by m square minus n square. So we got secant theta. So using the identity. So what did we understand when we started this? We can find, given the value of one t ratio, we can find the values of the other t ratios using the trigonometric identities. Why did we use secant square theta minus tan square theta as 1? Because we are given the value of tan theta. We are given the value of tan theta. So using this identity, substituting the value of tan theta, we can find secant theta. And the identity which is very important here in the simplification processes, a plus b the whole square minus a minus b the whole square is equal to 4ab. So with all this, we find secant theta. Now, once you find secant theta, you know cos theta because the reciprocal. Secant theta, its reciprocal is cos theta. Now you want to find sin theta. Now you found 4 actually because tan is given, so you know cot. And with secant, you found cos. Now we are left with sine and cosecant. If you find sine, you can find cosecant. It's reciprocal cosecant. So how to find sine? So here I found sine using the formula. Sine theta is equal to root of 1 minus cos square theta. So again, so this might be like suddenly she's writing all this. I don't know. It's all there in the introduction. Sine square theta plus cos square theta is equal to 1. You can write this also. You can write this and substitute also. Not that you should write this straight away. Sine theta is equal to root of 1 minus cos square theta. Not that you should write that straight away. You can also write this. Sine square theta plus cos square theta is 1. What is cos theta? M square minus n square. Okay. So you can substitute here. Sine square theta plus m square minus n square by m square plus n square. The whole square is equal to 1. So now you have to just work this and find the value of sine theta. I have written straight away that sine square theta is equal to 1 minus cos square theta on transposing. So sine theta is equal to the square root of 1 minus cos square theta. I've just written this straight away. You can use this, you can write this identity and you can substitute like this, simplify and get sine theta. I have written this straight away. Sine theta is equal to root of 1 minus cos square theta. So sine theta is equal to root of 1 minus cos square theta. And root of 1 minus cos square theta. What is cos square theta? Cos theta into cos theta. What is cos square theta? Cos theta into cos theta. That is cos theta the whole square. Cos square theta is nothing but cos theta the whole square. So what is cos theta? This one is cos theta. What is cos theta whole square? What is cos theta the whole square? So I've just squared the numerator and denominator. So square the numerator, square the denominator. That is cos square theta. That is cos square theta. This is the formula. This is the formula. 1 minus cos square theta. So cos square theta meaning you'll have to square the numerator and denominator. Square. It's the whole square. So the numerator is squared, the denominator is squared. And then again LCM. Like we did earlier, LCM. Now the numerator is of the form a plus b the whole square minus a minus b the whole square is equal to 4ab. Is equal to 4ab. 4ab meaning 4m square n square. A is m square, b is n square. 4ab, 4m square n square. So sine theta, sorry. So sine theta is equal to, root of, this one is 4ab. The numerator is 4ab using the identity. 4m square n square by this one as it is. Now we need to have the numerator and denominator as perfect squares. Only then you can get rid of the square root. You can get rid of the square root symbol only when the numerator and denominator are perfect squares. You can get rid of the square root symbol only when the numerator and denominator are perfect squares. So this 4m square n square should be written as 2mn the whole square. 2mn the whole square. 4m square n square is nothing but 2mn the whole square. 2mn the whole square. So how do you get rid of the square root? 2mn the whole square will come out as 2mn. And here also the square goes away. So m square plus n square. M square plus n square. So we found sine theta. Reciprocal is cosecant theta. Reciprocal is cosecant theta. And since we know tan theta, it's reciprocal is cot theta. Yeah, children, since it's time, take a screenshot and please finish this in your classwork. Please take a picture and complete this. Done, children? Okay. Class, use the emoji. Raise your hand. Nandini, Tarun Murali, Sashmin, Ananya, Raja Rajeshwari, Kanishka, Priyanka, Pranav Rajan, and Murali Krishna. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.